Hi guys, welcome back to my channel. In this tutorial we are going to look at this integral from 0 to pi over 3 of sine of x times cosine of pi over 3 minus x dx. So we are going to solve this using a famous identity which is called the King's property. So if you have the integral from a to b of f of x dx, that integral can also be written as the integral from a to b of f of a plus b minus x dx. That is just summing the limits, subtracting x from the result, and that should be equal to the original integral. So let's use this trick to solve this integral. So this integral, you can call this I. So I is the integral from 0 to pi over 3 of sine of x. So we are going to use the King's property now. So x here is going to be now 0 plus pi over 3 minus x. So that is going to be pi over 3 minus x, like this. Cosine of pi over 3 minus x, and x is pi over 3 minus x, like this, dx. So this is from the King's property. The King's property. So I is going to be the integral from 0 to pi over 3 of sine. This is sine, I'm sorry about that. So sine of pi over 3 minus x, cosine of pi over 3 minus pi over 3 minus x, that is this cosine of x, like this, dx. So this is from the King's property. So this is being transformed by the King's property, and this is the original integral. So we can add these integrals together. So we can have I plus I. The original integral is the integral from 0 to pi over 3 of sine of x and cosine of pi over 3 minus x dx, plus the integral transformed by the King's property. This is sine of pi over 3 minus x cosine of x dx. So I plus I is 2i. That is, this can be factorized. So integral from 0 to pi over 3, the integrals are the same. So you have sine of x cosine of pi over 3 minus x plus sine of pi over 3 minus x cosine of x, all this dx in a square bracket. Cool result. Now if we have this, we know that sine of a plus b is sine of a cosine of b plus cosine of a and sine of b. So this one looks like something like this from the double angle identity. So this one is the same as sine of a plus b. Our a here is x and our b here is pi over 3 minus x, like this. So we can rewrite our integral. So 2i is going to be the integral from 0 to pi over 3 of sine of x plus pi over 3 minus x, like this, dx, using the double angle identity. So 2i is going to be the integral from 0 to pi over 3 of the x's will cancel out nicely. Then we have like sine of pi over 3, and sine of pi over 3 is like sine of 60, and sine of 60 is the square root of 3 over 2. So sine 60 is the square root of 3 over 2 dx, which is a constant. You can go in front and have the integral from 0 to pi over 3 of dx, or 1 dx. So 2i is the square root of 3 over 2, and you are integrating 1 in the x world, that is x. And your limits of integration will run from 0 to pi over 3. So in the end, you have 2i is equals to the square root of 3 over 2 times pi over 3 minus 0, like this. So which is the square root of 3 pi over 6. We are not done. Yes, we have to divide by 2. So dividing by 2 you have your I to be equal to the square root of 3 pi all over 12. So that is the value of our integral. So our integral, which is the integral from 0 to pi over 3 of sine of x and cosine of pi over 3 minus x. So the integral I, which is equals to integral from 0 to pi over 3 of sine of x cosine of pi over 3 minus x. This is evaluating to the square root of 3 pi over 12. So that's the value of this integral. If you find this helpful, make sure to give me a thumbs up, subscribe to my channel for more content. Thank you so much for watching the video, and I will see you in the next one. Bye bye.